Good evening, class. So today we are having the topic permutations and combinations. So moving to the first question, a polynomial has 44 diagonals, then the number of sides are. See, we are having the general formula for the number of diagonals of a polynomial of side n. So coming to that formula is nc2 minus n. This gives the number of diagonals of a polygon of side n. But how are we going to remember this? Or what you can do here is, if you are having a triangle, then there will be no diagonal. But if you are having a four-sided polygon, then you can see you are having only two diagonals. So how these two diagonals can be made? First of all, I need to select any 2 points. So first of all, we need to select any 2 points on the polynomial. So in how many ways we can select any 2 points? If we are having an, let's say, n-sided polygon, okay, let's say it's going carried on. So first of all, out of these n vertices, we will select any two. These two should not be the adjacent one. So how many adjacent two combination we will be getting? N adjacent two combinations we will be getting. So except these nc2 minus n, this will give us the points which are not adjacent to each other, so a diagonal can be made. So this is the formula for the number of diagonals of the polygon of side n. So what we are given? We are given that its value is 44. So on solving, we will be getting n minus 1 by 2 minus n equals to 44. So that will be n square minus 3n equals to 88. See, here you will get a quadratic equation. N square minus 3n minus 88 equals to 0. You can either solve it like n square minus 11n plus 8n minus 88 equals to 0. So n minus 11 into n plus 8 equals to 0. You will be getting 11. Or the other way is, since n belongs to a whole number, or we can say a natural number, then taking n common, we will be getting n into n minus 3 equals to 88. 88 is 11 into 8. So we can see here, if n is equals to 11, then n minus 3 is equals to 8. So we can directly say n will be equals to 11. You don't need to, you are not required to solve this quadratic equation then. You can analyze these two and get the value of n. Now moving to the next question. An n-digit number is a positive number with exactly n digits. 900 distinct n-digit numbers are to be formed using only the three digits 2, 5, and 7, the smallest value of n for which this is possible. So, if we will see, then the number of numbers that we can form will be, for the first number we are having three options. We can use either 2 or 5 or 7. For the second, we are again having three options. For the third, we are having three options, and so on. See, from the fundamental principle of counting, we know that we have to do this and this, and we have to arrange this also. And so when we are using the and term, then we need to multiply. So then the total number of ways will be 3 into 3 into 3 into so on up to n times. Now, this will be 3 to the power n. And we are asked that an n digit number is a positive number with exactly n digits. 900 distinct n digits number we have to form. So this value should be greater than or equals to 900. We know that 3 to the power 6 is 7 to 9. 3 to the power 7, we are having 2187. So we need more than this terms. So 6 is not our answer. Our answer is n equals to 7. That is option B. So your option is correct path. Moving to the next question. NCR plus 2, NCR plus 1 plus NCR plus 2. So we already know the property NCR plus NCR plus 1, that is equals to N plus 1 CR plus 1. So you can see here that it is NCR plus NCR plus 1 plus NCR plus 1 plus NCR plus 2. So these two will become N plus 1 CR plus 1, and these two will become N plus 1 CR plus 2. Again, this quantity here, it is same, and there we are having a difference of 1. So this combined will give us the answer N plus 2 CR plus 2. So our option C is correct. Good, Manvi. Moving to the next question. The number of arrangement of the letters of the word banana in which the two ends don't appear adjacently. Okay, I am giving you 30-second time. No. Okay, let's do it. So we don't have the two ends should not come adjacently. Let's see in how many ways we can arrange it. In how many ways we can arrange it? 1, 2, 3, 4, 5, 6. That will be 6 factorial upon 3 factorial into 2 factorial. That will be 6 into 5 into 4 upon 2. So this will be 60 ways. In 60 ways we can arrange it. Okay, so 80 cannot be the answer. And no n's 2 should appear adjacently. So let's take both the n as a single unit. So we will be having B, A, and both the n's as a single unit. So we are having 1, 2, 3, 4, 5 units here. In how many ways we can arrange it? 5 factorial upon 3 factorial. That will be 5 into 4 into 3 factorial by 3 factorial. On cancelling, we will be getting 20. So the total number of ways in which this should not appear adjacently is 60 minus 20. So our option is A, that is 40. Good, Manvi and Param. Moving to the next question. Again, 30-second time. The question is the number of points with integer coordinates that lie inside the triangle whose vertices are 0, 0, 0, 21, and 21, 0. Anyone? Arushi? No, man. You don't have to be quick. You need to be accurate first. Okay. So let's see. See, we have to find all the coordinates. So if we are having the value of, say, this will be 1 comma 0, 2 comma 0, and so on 20 comma 0. So for 1 comma 0 we can go up to 0 comma 20. This coordinate will be 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, and so on up to 1 comma 20. So how many options we are having here? So we are having 19 options here. Then again for this we will be having 18, 17, and so on up to for 20 we will be having only one option. So writing this, the total will be n into n plus 1 by 2, n into n plus 1 by 2. So our option will be 190. 198, yeah, correct. Going to the next question. So our question is, a rectangle has sides 2m minus 1 and 2n minus 1 units as shown in the figure, composed of the squares having edge length 1 unit, then the number of rectangles which have odd unit length. See how many ways you can solve it. First, theoretical ways, and the other you can go for the objective ways. Put m equals to 1 and n equals to 2. So you will be having 1 and 3. So we are having a rectangle. Okay, put this also 2. So you will be having a rectangle with 3 and 3 sides. Will it be good for you? We will do it at the end. So first of all, what we can do is we should do the subjective way only. So see here from n equals to 1 to we are having m equals to 2m. So if we will have to find the odd unit length, so that length can be either 1, or that length can be 3, or that length can be 5. So if we are having this 1 here, then if we are selecting the number 1, then this is an odd number. So we have to select the other number which should be an even number, either 2, then unit length will be 1, 4, then the length will be 3, 6, then the length will be 5. So out of this 2m numbers, first number we have to select is odd. So number of ways in which an odd number can be selected is MC1. Out of these m we have to select one odd, and out of these m we have to select one even. So this is how we have found this length to be odd. Now here also we need to find the odd length. So out of these n options we have to select one even and one odd. We have to do this operation also and this operation also. So our option will be MC1, that is m into m into n into n. So that will be m square into n square. See, we are given the sides are 2m minus 1 and 2n minus 1. So we have numbered these values from 1, 2, 3, 4 to 2m. So the sides will be 1 less. That will be 2m minus 1 sides. Now, what we have to select? We have to select odd unit length. How we are going to select an odd unit length? If you are taking it by the numbers, then out of these 2m numbers, what we have to do is we have to select the two values whose difference should be odd. So if one value is odd, then the other value should be even. Then only the difference is odd, and that difference will give us the length. And for this, we can say height. From these two n values, we have to take one value even and one value odd, so that that difference will give us the odd length. So this is how you can find the length to be odd and the height to be odd. Clear? Arushi Manvi Param Path Vamsi. So our correct option is option D. Moving to the next question. We are given if R, S, T are prime numbers and P and Q are the positive integers such that the LCM of PQ is R square T to the power 4 and S square, then the number of ordered pairs P and Q is. Anyone? So what is the basic concept of LCM? If I say, let's say if I am having some A, that is 2 square into 3 to the power 1, and B we are having 2 into 3 to the power 3. So what will be the LCM of AB, or this ordered pair LCM? 2 square 3 cube. So if we are having R square here, then we can say for P we are having the option, if R to the power 0 is here, then Q should have R square. If P is having R to the power 1, then Q should have R square. If P is having R to the power 2, then Q can have the values 0, 1, 2. So these are the possible outcomes for R square. So how many outcomes are there? We are having 5 outcomes. Similarly, if we look for T, then T to the power 4 we are having, then P, Q. If we are having T to the power 0 here, then there should be T to the power 4, T to the power 1 here, then it should be T to the power 4 in Q. If we are having T to the power 2 here, then again T to the power 4 should be there, 3, then T to the power 4 should be there. And if we are having T to the power 4 into P, then we are having all the options T to the power 0, 1, 2, 3, 4. So how many options? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are having 9 options for T. And since it is S square, so similarly for R square, for S square also we will be having 5 options. So the total number of options will be 25 into 9, that is 225. So the correct option is B. So general formula is, if you are having, let's say the LCM of PQ is R to the power A, T to the power B, and let's say S to the power C, then the number of ordered pairs you will get is 2A plus 1 into 2B plus 1 into 2C plus 1. Okay, see, R to the power A we are having, so this can have the values ranging from 0 to A, but both cannot have the values 0 0. So that's why you will get the option 2A plus 1. So our correct option was B. Now moving to the next question. Giving you 30-second time for this. The question is, the letters of the word Cochin are permitted and all the permutations are arranged in the alphabetical order as in the English dictionary. The number of words that appear before the word Cochin are. Good, Param. The right answer is C. So if we are going for before Cochin, then we know that if we write it alphabetically, then CC and the rest 4 can be arranged in 4 factorial ways. Then CH and the rest 4 can be arranged in 4 factorial. Then CI and the rest 4 can be arranged in the 4 factorial ways. CN and the rest can be arranged in 4 factorial ways. Now after doing this, we will be having CO, then alphabetically C we will be having, then H, then I, then N. So this is our word. So before this, how many words are formed? That is 4 times of 4 factorial. That value is 96. So our correct option is option C. Moving to the next. Okay, again 30-second time. The number of 7-digit numbers with sum of the digits equals to 10 and formed by using the digits 1, 2, and 3 only is. Speed up, speed up, speed up. So how we are going to do this is, the number of 7-digit integers with sum of the digits equals to 10 and they are formed by using the digits 1, 2, and 3. So we know the basic coefficients idea. Let's say the digit, one digit is formed by this. So the powers that will give us value 1, 2, and 3. So the other digit will be x to the power 1, x to the power 2, x to the power 3, and so on. We are having 7-digit integers, so all the 7 places we will be having this. And what we have to find out is, we have to find out the coefficient of x to the power 10. So coefficient of x to the power 10 in this. Yeah, correct Parth. So we are taking out x common. So the coefficient of x to the power 10 in x will come out with the power x to the power 7, 1 plus x square. So from here we can see that each term will be multiplied by x to the power 7. So what we have to do, we have to find only the coefficient of x to the power 3 in the expansion of 1 plus x squared to the power 7. So from binomial we can expand it. So that will be 7c0 plus 7c1 into x plus x square plus 7c2 x plus x square whole square plus 7c3 x plus x square whole cube and so on. These all terms will have more higher values of x to the power 4, x to the power 5. So no coefficient will come out from this. And this is also not having the coefficient of x to the power 3. This cannot have the coefficient in x to the power 3. Only these two terms we are interested in. So from this 7c2, if you will expand it, you will get the general term, or you can say if you will keep out x, then it will be x square. So we need to find the coefficient of x in 1 plus x to the power 2. So that will be 2c1 plus, if we will take out x from here, that will be x cube. So we need to find the coefficient of x cube only. So it will be the coefficient of constant term in 1 plus x to the power whole cube. So that will be 7c3 into 1. On solving this, 7c2 will be 21 into 2 plus 7c3, that is 35. So our answer will be 77, that is option number C. So C is our correct option. Moving to the next question. The total number of ways in which 5 balls of different colors can be distributed among 3 persons so that each person get at least one ball is. So let's say we are having 3 persons, P1, P2, P3. We are having 5 different colors balls. So if this guy is having, because each one is getting at least one, so if he's getting one, then how many balls we have to give him? 3. If he is having fun, he is having 2 and he is having 2, then also 5 are distributed. We can arrange this distribution and we can arrange this distribution also. So we can find the number of distributions for this case. So for this, 5c1, 4c1 into 3c3 plus either this is the case 1 or case 2. So when we are writing or, then we are putting addition sign, and this will be 5c1 into 4c2 into 4c2. Now these options can be arranged. See, P1, P2, P3, we can arrange. We can write P2 here, we can write P1 here, we can write P3 here only. So P1, P2, P3 can themselves be arranged in the ways 3 factorial. So on solving this value, you will get 150 as your answer. So correct option is option B. Correct, Manvi. Now, moving to the next question. The number of different 7-digit numbers that can be written using only three digits 1, 2, and 3 under the condition that digit 2 occurs exactly twice in each number is. Giving you again 30 seconds time. So see, we have to form a seven-digit number, and we know that two should appear exactly twice. So if we are having one, two, three, four, five, six, 7 digits, let's say two we are having here. Now we are having five places, and we are having two options. We have to put either one or three. So in how many ways we can either put one in each place? So in how many ways we can arrange it? 7 factorial upon 2 factorial into 5 factorial. Secondly, 2 we are fixed. Now for the rest places, we can put 4 1 and 1 3. So that will be 7 factorial upon 4 factorial into 2 factorial. 2 factorial is for 2 and 2. Then again 3 1 and 2 threes. So that will be 7 factorial upon 3 factorial into 2 factorial into 2 factorial. Then two ones and three threes. That will be similar to this. Then one one and four threes. That will be similar to this case. And again no one and five three. That will be similar to this case. So we can say that we are having two times of each of this case, that is 7 factorial upon 2 factorial into 5 factorial plus 7 factorial upon 4 factorial into 2 factorial plus 7 factorial upon 3 factorial into 2 factorial into 2 factorial. So how we can solve it? 7 into 6, 5 factorial will cancel out. This will be 2. From 2 we can cancel this, plus 7 into 6 into 5 into 4 factorial, that will be 2 here. We will be getting this, plus 7 into 6 into 5 into 4 into 3 factorial will get cancel out, and 2 into 2 will get cancel this 4 out. Okay, so the total number of ways on counting, we will be getting 672. So the correct option is A. Now moving to the next question. Now, the question is, we are having five Indian and five American couples meet at a party and shake hand. If no wife shakes hand with her own husband and no Indian wife shakes hand with a male, then the number of handshakes that takes place in a party is. Right, 30 seconds. So yeah, we got one answer. Answer D, no. Answer D is not the correct answer. Okay. So what we are having here is, let's see, five Indian, five American couples. So we are having Indian males, Indian women, American man, American women. Okay. So five, 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 and five. Now, if no wife shakes hand with her own husband, so for each wife, or we can write it like, we are having Indian male, American man, and Indian wife and American wife. Now, no wife shakes hand with her own husband. It is given. So, how many handshakes are possible? First of all, we can see that each Indian man and Indian male can have a handshake. So, in how many ways they can do it is 5C2, that is 10 ways. Similarly, Indian woman and Indian women, American man, and American women and American women. All these will have 10 ways of handshaking. So that comprises to our 40. Now, moving to the next options. Indian man and American man can have a handshake. These are five and these are five. So for this each person, we are having the five options. So the total number of handshakes will be 25. So you are having 40 there plus 25. Similarly, no restriction on woman to woman handshake is there. So Indian women can have a handshake with American women. Again, they are 5 and 5. So the total number of options will be 25. Now, we are also given that no Indian wife shakes hand with a male. So there is no such option and there is no such option. But there is no restriction on Indian male and American women. So in how many ways they can have the handshake is 25 ways. Now the leftover is American man and American women. It is also given that no wife, be it Indian or American, will shake hand with her own husband. So the total number of ways will be, for each man there will be four options, because the man can have handshake with any other woman except her wife. So there will be 5 into 4, that is 20 options. So these are the total number of handshakes these are possible. So summing this value 5 and this is 13. So we are having the option C 135. Clear? Moving to the next question. A road network as shown in the figure connect four cities. In how many ways can you start from any city, let's say A, and come back to it without traveling on the same road more than once? So you don't have to repeat the road. So in how many ways we can do it? Let's say we start from the A. So we are having three options to go. We can either go to B, we can either go to D, or we can either go to C. All these three options are symmetrical. If we'll go to B, then we are having again two roads. If we are going to D, then we are again having two roads. And if we are going to C, then again we are having two roads. So the three options are same. So we can say that we are having three options. Let's select any one of the options. Let's say we have reached B. Now we have to, it is not given that you have to cover all the cities or anything. So we have to go back to A. So in how many ways? Can we go directly from B to A? No, we cannot travel the same road once. Can we go from B to C, then C to A? Yes, that is one option. Or can we go from B to D and then from D to C and D to A? Yes, that is also one option. So if we will travel to D or we will travel to C, then how many options we are having? Two options we are having. If we reach to D, then we can directly go to A, or we can go from C to A. And if we have reached to C, then again we are having these two options. We can directly go to A or from D to A. So we can say that if we have reached any one of the city, let's say we have reached D, then we are having again two options. So in this ways we can travel. So that will be 12 options. So our correct option is option number B. Moving to the next question. There are n identical red balls and m identical green balls. The number of different linear arrangements consisting of n red balls. So we have to select all the red balls, but not necessarily all the green balls. So green balls have that option. So red balls all n, and for green balls the value can range from 0, 1, 2 and so on up to m. So let's say we are having red balls, or we can write green for the green balls. See, red balls are fixed. So green balls 0, 1, 2, so on up to m. So if we are having 0 green balls, then we are having all the n red balls. So in how many ways we can arrange them is one way, since it is given that they are identical. Now if we are having one green and n red balls, then we are having total number of n plus 1 balls, in which n balls are identical, so the number of ways will be n plus 1 upon n factorial. If we are having two green balls, then the number of ways of arranging them will be n plus 2 factorial upon n factorial into 2 factorial. And for m, it will be n plus m factorial upon n factorial into m factorial. So we can see the total ways are m plus n plus 1 factorial upon n factorial plus n plus 2 factorial upon n factorial into 2 factorial plus n plus 3 factorial upon n factorial into 3 factorial, and so on up to n plus m factorial upon n factorial into m factorial. See, this we can write as n plus 1 c1. This is n plus 2 c2 plus n plus 3 c3 plus n plus 4 c4 and so on up to n plus m cm. But we are having the option in the form xcy. So we know the property from here. We can see if we would be having n plus 1 c1, and if we will be having n plus 2 c1 and n plus 1 n plus 2 c2, then that would have become n plus 3 c2. So we can write this one as n plus 1 c naught. So if we will look at only these two quantities, then it will be n plus 1 c0 plus n plus 1 c1, that will be n plus 2 c1. And then if we will combine this together, then it will be n plus 1 c1 plus n plus 1 n plus 2 c2, so it will be n plus 3 c2. Now combining this, we will be getting n plus 3c2 plus n plus 3c3, that will be n plus 3c4. So similarly, if we will be getting till end, it will be n plus m plus 1 cm. So the value of x will be n plus m plus 1, and the value of and the value of y should be m. So the correct option is option B. Good. Now moving to our next question. It is given Sn is equals to summation r equals to 0 to n 1 upon ncr, and Tn is equals to summation r equals to 0 to n r upon ncr. We need to find the value of Tn upon Sn. So Tn we can write it as 0 upon nc0 plus 1 upon nc1 plus 2 upon nc2 plus so on up to n minus 2 upon ncn minus 2 plus n minus 1 upon ncn minus 1 plus n upon ncn. We know that ncr is equals to ncn minus r. So we can reverse these digits and we can write it as, for this nc0 we can write it as ncn, for nc1 we can write it ncn minus 1, for nc2 we can write it ncn minus 2, and similarly n minus 2, for ncn minus 2 we can write it nc2, for n minus 1 cn minus 1 we can write it n minus 1 nc1, and for n upon ncn we can write it n upon nc0. If we'll combine these two, then 2 times of Tn will be n upon nc0 plus, denominators are same, so n minus 1 plus 1 will be n upon nc1 plus n upon nc2 plus so on up to n upon ncn minus 2 plus n upon ncn minus 1 plus n upon ncn. Taking n common, we will be getting 1 upon nc0 plus 1 upon nc2 plus 1 upon nc1 plus 1 upon nc2 so on up to 1 upon ncn. So this value is our Sn. So what we are having is 2 times of Tn is equals to n times of Sn. So Tn upon Sn will be equals to n by 2. So the correct option is option A. Moving to the next question. If the letters of the word Sachin are arranged in all possible ways and these words are written out in dictionary, then the word Sachin appears at the serial number. So if we write it alphabetically, then A will come at first, then we will be having C, then H, then I, then N, and then S. So first of all, at first place, if we are having A, then the rest 5 can be arranged in 5 factorial ways. Yeah, correct. If you are having C in here, then again 5 factorial, H 5 factorial, I 5 factorial, and 5 factorial. So when we will start with S, A will be there, then alphabetically it will be C, then alphabetically it will be H, then I, then N. So this will be our one word. So these are 5 into 5 factorial, that is 5 into 120, so 600 this, and Sachin is at the position 601. Good. Manvi and Param. Correct answer. Now, I am giving you 30 seconds for this question. Do it. This is 56 minus r C3. Summation r equals to 1 to 3, and this is 54. It is a very simple question. You have to just use one property we have already covered. Okay, so let's start it. We already know NCR plus NCR plus 1, it is equals to N plus 1 CR plus 1. So we are having 50C4 plus, if we'll put R equals to 1, that will be 55 C3 plus 54 C3 plus 53 C3 plus 52 C3 plus 51 C3, and this will be 50 C3. So I'm writing this 50 C4 at the end. So combining these two, we will be getting 51 C4. Then 51 C3 plus 51 C4, we will be getting 52 C4. Combining these two, we will be getting 53 C4. These two will be getting 54 C4. Combining these two, we will be getting 55 C4. And combining these two, we will be getting 56 C4. So our correct option is D, and good. Yeah, D is correct. Now moving to the next question. So the question is, in a shop there are 5 types of ice creams available. A child buys 6 ice creams. Now statement 1 is the number of different ways the child can buy the 6 ice cream is 10c5. And the statement 2 is the number of different ways the child can buy the 6 ice cream is equal to the number of ways of arranging 6 A's and 4 B's in a row. Okay, want to try it? Giving you 30 seconds time. Just think over it, then we will start solving. Okay, so how we are going to solve it is, there are 5 types of ice creams and a child buys total of 6 ice creams. So we can see that if we are having, let's say x1 represents the number of ice creams he is buying for type 1, x2 represents the number of for type 2, x3 represents the number for type 3, x4 represents the total number for type 4, and x5 represents the total number of for type 5 ice cream. And this sum should be equals to 6, and the value of x1, x2, x3, x4, x5 can range anywhere from 0 to 6. So we already know how to solve this type of questions. See, the value of x1 will be from 1 plus x square plus so on up to x to the power 6 into 5 times this will be this, and from binomial it will be 1 minus x to the power 7 upon 1 minus x whole to the power 5, that will be 1 minus x to the power 7 to the power 5, into 1 minus x to the power minus 5. So what we have to do is we have to find the coefficient of x to the power 6, because the total value should be 6, from the expansion of 1 minus x to the power minus 5. So we have to find coefficient of x to the power 6 in the expansion of 1 minus x to the power minus 5. So we know the formula for this. The formula is, if we have to find the coefficient of x to the power r in the expansion of 1 minus x to the power minus n, then that coefficient is, or in books you will find it n and this here r. Okay, so let's write it in that way. N plus r minus 1 c r minus 1. Okay, so here we are having n equals to 6, so that will be 6 plus 5 minus 1 c 5 minus 1, so that will be 10 c4. Okay, I guess some yeah. So our statement 1 is false. So only option that matches is option number A. Or we can go for the second statement also. The second statement states that the number of different ways the child can buy the 6 ice cream is equal to the number of different ways of arranging 6 A's and 4 B's in a row. So total we are having 10, out of which 6 are identical and 4 are identical. So this will be either 10C4 or you can write as 10C6. Both are same, so our option is 10C4, and here also it is 10C4. So the correct option is A, because statement 1 is false and statement 2 is true. Clear? Want me to repeat it? Moving to the next question. In how many different words can be formed by jumbling the letters in the word Mississippi in which no two S are adjacent? So we are having Mippi, and we have to jumble them in such a way that no two S are together. So S cannot occupy adjacent positions, but they should be in between all these alphabets. So in how many ways we can arrange these? 1, 2, 3, 4, 5, 6, 7. So that will be 7 factorial upon 2 p's are identical and 4 i's are identical. We have to do this, and out of these 1, 2, 3, 4, 5, 6, 7, 8 places, we have to select any 4 places where we will place the S. So these are the total number of ways. So 8C4 we are having, and we are having this 7 into 6 into 5 upon 2, so that will be 7 into 5 into 3 into 8C4. No options matches are that condition, but if we write it as 7 into 6 into 5, or 7 into 6 factorial upon 2 factorial into 4 factorial into 8C4, then it is 7 into 6C4 into 8C4. So the option that matches our condition is option number D. Clear? Okay. So that's all for today. Thank you, everyone.